The William W. Hay Railroad Seminar Series is sponsored by the National University Rail Center here at the University of Illinois at Urbana-Champaign. And on behalf of all of us, we thank the US DOT for their support. It's greatly appreciated by those of us here on campus, as well as those participating via the internet. Let me first welcome those of you who are joining us via the internet. We have representatives from Metra, Amtrak, McCormick Taylor Incorporated, CSX, HDR, BNSF Railway, Boise State University, Genesee and Wyoming Railroad, Hanson Professional Services, Trans Systems, Patrick Engineering, HNTB, and the Association of American Railroads. We welcome you, and if any of you would like to receive PDHs, Continuing Education Units, for your participation, please send LB an email with your information as described in the email announcement for this seminar. Today's presentation will provide insight into how 7 specific civil engineering disciplines are applied at the Union Pacific Railroad. The subject disciplines provide the technical foundation necessary for the engineering department to provide safe, reliable, and efficient track infrastructure across 33,000 miles of their track network. Our speaker today is Eric Gehringer, who is Assistant Vice President of Track Programs at the Union Pacific. He received his BS degree in Aerospace Engineering from St. Louis University and an MBA from the University of Nebraska. And I will note that this is the second Hay seminar in a row where the speaker's BS was in Aerospace Engineering, so I don't know if there's a trend here. He's worked for the Union Pacific for 11 years, and his experience includes positions in track maintenance, track research and development, work equipment, and track renewal operations. In his current role, he leads a team of 3,300 employees responsible for $1.1 billion of track renewal annually. Now, before Mr. Gehringer begins his presentation, we thought it would be useful to provide a brief introduction to the Union Pacific Railroad, and Mr. Gehringer's colleague, Mr. Tom Haley, has kindly agreed to provide us with that. So please join me in welcoming Mr. Eric Gehringer and Mr. Tom Haley, who will present the William Hay Railroad Engineering Seminar entitled 7 Disciplines of Engineering at Union Pacific Railroad.
All right. Thank you, Chris. Thank you for having us. Thank you all for being here. It's a pleasure for us, an opportunity to talk with you, and I thank you for that. Do we have a clicker? All right. My name is Tom Haley. I am Vice President of Network Planning and Operation at Union Pacific. My part of the business is the design of the operation. So all of our train schedules, our capacity planning, our resource planning, our analytics around the operation, and several other areas are in my group. So I'm just the warm-up act. Eric here is going to talk to you about engineering topics. Yes. Oh, yeah, okay. Thank you. Chris said, talk a little bit about Union Pacific. I said, oh, come on, it's a Hay seminar. You all know what a railroad is and what a railroad does. He said, well, not necessarily. So I'll give you just 2 or 3 thoughts here that might help you understand us and what we're doing in the private sector as a business. That's a map of Union Pacific. If you don't know who we are, we're a large western railroad. We cover the western 2/3 of the United States. We have about $20 billion revenue company, 8.5 million carloads of freight last year. We generated that for 10,000 customers across 32,000 route miles, about 43,000 employees. You can see our numbers there. Our franchise is unique in that we serve the ports on both the West Coast and the Gulf, and also the Mexican gateways. Union Pacific, like all the big railroads, hauls a surprising variety of traffic, freight traffic. We are, and a railroad in general, is a very versatile transportation device. Okay, we haul the aggregates and raw materials that build buildings. highways. We haul intermediate goods in the supply chain. We haul perishables and very time-sensitive freight. I think of it in terms of shelf life, right? So we have a booming rock, sand, aggregates business. That stuff is as old as the planet. And we have things that have a shelf life of a week that we haul. Trailers full of packages of cookies from grandma going to people, oranges, wine, and everything in between, automobiles, the clothes you wear, the products of food touched a railroad at some point in the United States and maybe multiple points. Our value creation is around these basic tenets. In the interest of time and giving it to Eric to talk more specifically about engineering, I'm not going to dwell on these, but I will just highlight them. Safety is very important in our industry. I'll show you a stat here in just a minute. We've made tremendous improvement in our safety record at Union Pacific and in the railroad industry in general. We have an excellent customer experience core value, which is about selling our services. So we're in business in the marketplace. If we don't provide a great product, shippers have alternatives. They go someplace else. We got to provide value to our shippers, and it's the total experience we're after when we do that. We infuse our operation with innovation in many ways. You're going to see some of that when Eric speaks. We're very asset intensive. So I mentioned earlier 8,000 locomotives. Any one time we have 275,000 freight cars on our network, 32,000 miles of railroad, 43,000 people. It's very important we design and operate for high productivity with great service. Our franchise, you know, a railroad's very limited in some ways by where it goes, but we think beyond our boundaries. And you'll see us doing that in many ways. And engaging our team, you know, 43,000 people is a great resource. And so we constantly work to bring out the creative energy in as many as we can. Just a couple quick slides here. Safety. So here's railroads. Lower is better, right? This is a frequency of injuries and illness. Railroad industry as a whole is a safe industry, despite what we do. And Union Pacific is the safest among the big railroads. We have the best safety record. We're 2 years running on that. It's a little bit of our history. Again, lower is better. These are all rates. We define safety in terms of our employees, equipment, which would be accidents with equipment, and grade crossings, which is the public. And we've made significant progress in all those areas and intend to keep going. Our goal is 0. We want 0. We're a very green business. Some of you know this. Rail is about 4 times more fuel efficient than truck. We haul a ton of freight, more than 500 miles, for 1 gallon of diesel fuel. On average, that's our system average. That's a great tailwind for us going forward. Trucks off crowded highways, very fuel efficient and green. That is a natural advantage, and it's for all the railroads. Capital investment was one of our core values there. What I want you to see here, these are the different categories of what we spend our investment on. Again, we're a private enterprise. We own our own infrastructure. We own our equipment. We maintain it. We renew it ourselves. And we do all that out of the revenue we raise by selling our service. So you can see why service is so important, right? It brings in the revenue so we can do this. And on top of all that, we pay taxes, and we try to do good in our community with public institutions such as this one. 60% of our capital budget is an infrastructure replacement. That's ties, rail, ballast, bridges, all the infrastructure that is our railroad. And that's what Eric's going to talk about here in just a minute. The rest of it's around locomotives. You can see the other categories here on what we invest in. So I'll just stop by giving you this. We usually start our presentations with this. I'm going to use it as a handoff to Eric in this case. We're a service organization. Our product is service. Our employees are dedicated to serve. Our values are performance, ethics, and teamwork. We go round and round that circle, and we try to do that in everything we do and exhibit those values. So in the spirit of teamwork, I'm going to give it to my team member, Eric here, who has, I don't know if you read the bio on the thing, but Eric's got a big job at UP. He runs track programs. So I'm just going to back up one here. So the programs inside of here that replace ties and rail, he runs. So I think you've got 3,000 employees that ultimately pyramid to you. So Eric can talk a lot about this. Okay, thank you very much. Eric, it's all yours.
Okay, good afternoon. Can you hear me okay? In the back? Okay, perfect. Thank you, Tom. So again, like Tom said, thank you very much for being here, both the people here in this building and also people on the web watching. You know, we kept the content here pretty short. The most important thing for me being here is to really answer any questions you have, whether it's questions about the content we're going to share or just anything you'd like to know about UP. Before we jump into this, let's go through kind of why we're here sharing this, right? As Tom mentioned, we want to come in here, we want to educate you on what Union Pacific is, what we represent, what we do. But when you think about you as all being engineering students or people in the engineering field, right, we want to provide opportunities to you. We want you to be able to gain insight into what is the Union Pacific interested in, whether that's safety or reliability or efficiency. On top of that, you know, it's our strong hope that some of you will consider Union Pacific as your future employer, right? And Tom mentioned the many things that make Union Pacific an excellent company to work for. And so as we talk through this, it gives you some insight, even down to a specific job, what that person does on a day-to-day operation. So let's jump into this with 7 principles. So here's the first one, material management. So we had a good discussion about this last night. You know, you think about material management in the world of engineering here at UIUC, and that can take a whole bunch of different forms, and many of them are listed here on the side. And you've done a tremendous amount of research that we have benefited from at Union Pacific as well as the rest of the industry. Where I'm going to challenge you to see a less obvious opportunity, though, it's not necessarily in differential equations. What you have here is an opportunity where when we say, okay, we want the best material, we don't always mean we want the material that lasts the longest. And that's counterintuitive to some people, right? As an engineer, you're challenged to think, what is the best design I can possibly provide, and then put that design on the market for people to utilize. What I'm going to challenge you with is the opportunity is to really optimize that design for our what we call renewal cycle. So if we know, and we do very definitively, that 141-pound, 1% carbon steel lasts 3.8 billion gross tons, we don't necessarily want a pad or an insulator for a concrete tie that lasts 4.5 billion gross tons. Because when we come in, as Tom mentioned, as part of the renewal, we take all of that out and we put in all new. So we effectively have lost some usable portion of that asset's life, right? About 700 million gross tons. So this is where we see the opportunity in material management. Yes, we want better wood ties and concrete ties, but again, those are obvious. You all know that. That's why you're here. Think about the less obvious ones, and again, it's an optimization problem in most cases. The next one's transportation. So there's 3 parts to this. As a principle of engineering, right, this does represent that principle in a practical way at a Class 1 railroad, right? On the left-hand side, vertical axis, you've got track quality. On the right-hand side, you've got time, right? And time can be measured literally in seconds or minutes, but it also can be measured in cycles, million gross tons, and years. So pick whichever one you like as you think about this chart. There's never a better time for the track quality than when it's absolutely brand new. But what we accept over time very knowingly, is that track is going to degrade, just like a bridge, just like a signal system, no matter how good you build it. And what you find is, though, we don't want to get into this bottom part here, right? That's the slow order. Slow order is where we, Union Pacific and other Class I railroads, purposely and very diligently reduce the class of our track because of an existing condition in the track, right? It could be wide gauge, it could be cross level, it could be a mud spot, right? Once we get in there, on some level we have failed. Where we want to be is in this UP standard, right? That's the intervention zone. That says that if the threshold for a slow order is here, let's stay up here so when we finally get into this zone, we're doing the renewal, and now we're not having to contend with the slow order because it unto itself poses a risk, not only from a safety perspective, but also from a business perspective on trying to efficiently move freight. So you look at that, and you say, okay, well, where's the opportunity? It's right here. It's this renewal event. We have done a tremendous amount of good work, not only as a railroad, but also as an industry, to determine what is the best renewal cycles. You know, when should you replace a wood tie on an 80 million gross ton line that's 9 feet long? But we have way more opportunities to still refine that. We are really looking to people like here at UIUC and other expertise that can be brought down to say, okay, what is that intervention cycle? And we've done some work here, right, especially in the areas of ballast and some on concrete ties, but there's more to come. So if you have that opportunity to spend any time doing that, please take it. We're very interested in it. Here's the other two. On the left-hand side, minimizing footprint. So you think about what Tom described, 33,000 miles of track. But see, on any given day, we don't get to utilize all that track. Right? Why don't we get to utilize all that track? Somebody. Yes, sir. That's true. Yep. From an engineering perspective, though, why don't you think we use that? Yes. That's it. That's exactly right, right? Somebody's got to be out there repairing it. Tom mentioned to you that we spend, $1.1 billion billion doing renewal. Those aren't done by a group of 3 or 4 women and men. Those are done by gangs of 100 men and women, paired together with another gang that has 100 men and women. And they're out there for 10 hours replacing 5,000 ties a day. Right? That's a problem for us when we're talking about fluid capacity of the system. So what you have here on the left-hand side is a very simple example of the things that we see as opportunities. It's a portable turnout. Right? Think about a subdivision. Now let's make it as simple as we possibly can. It's 100 miles long, and every 20 miles is a siding, right? So I'm at least, on any given day, if I'm in between sidings, going to travel 10 miles out to my work site, 10 miles back. Now if I can take a portable turnout that also includes portable track, and I can place that right next to our work site, now this gang that would normally spend 2 or 3 hours traveling, they may spend 20 minutes traveling. That means that we're being far more productive, and the impact to the system is less. A project that may have taken 40 days, if we didn't have this, now takes 30 days. It's a huge opportunity for us is how do we get more efficient on how we utilize all the technology to reduce that footprint. Second, risk identification. Think about a railroad, even if you don't know a lot about it, it runs the whole spectrum from a human being track inspector to a $12 million geometry car. And there's a whole bunch of things in between, right? Detector cars, GMS cars, you've got clearance cars, I could go on, and there's like a suite of like 15 of them. We see an opportunity to say, how do you compress that? You don't want to sacrifice the quality of the inspection in any way. In fact, you want the quality of the inspection to continue to get better. But how do you take that and move it down? So the presentations we saw this morning and some of the discussions I had last night, they were exactly that, right? They were saying, how do you take an existing data source like geometry car defects, whether they come from a railroad or the FRA, combined with slow order data, and say, okay, what's the right time to go in there and do something, right? That's what this is all about. And this is an autonomous geometry vehicle. So now we've doubled down on our benefit, right? We don't have to run a dedicated vehicle. We can just put this in the consist of a train. And at the same time, if we can leverage what it tells us to make better inspection decisions, then we're not taking up as much capacity on the system. Structures. Structures is so unique. Why do you think it's unique? This is the interactive part. talk to anybody I know, they know I don't like to stand up here for 45 minutes and just talk. Why is a structure asset different than maybe a wood tie or some rail?
It's a lot more expensive.
Yes, very true. A lot more expensive. And you're a future OMT in the bridge group, so you'll know that better than anybody soon. Why else? That's half the story, and there's one part that we're missing still. Yeah? Maintenance is different, that's true. I'm going to come to this side of the room, because this side's not really talking. There. Who said that? It lasts longer, that's right. It's a 100-year asset in some cases. In fact, in most cases, right? So the opportunity you take when you can say it costs a lot of money to maintain and repair and replace, combined with we have to keep it for a long time, the opportunity should be clear, right? It's how do you do the absolute best monitoring and inspection of that asset to make sure you get the most life out of it. It's no different. I was with a gang just a few days ago, and there was a large piece of equipment we had, and they had a crack. It was this massive steel beam, and they had 2 cracks on the end of the beams. Happened at the exact same time. But a different mechanic worked on each one of the cracks to fix. This mechanic, when the crack was only an inch long, he stop drilled it. The other mechanic didn't do anything, right? Well, sure enough, yeah, the crack had already grown 4 inches. It's a gross oversimplification of what it means to be monitoring and doing inspections, but the theory still applies. If we can inspect our structures, whether it's through physical inspections that are improved with new technology, or whether it's using data, or whether it's doing condition monitoring, we're going to add a lot of value when it comes to bridges. Environmental. So environmental, some people struggle with. They say, is it really a principle of engineering? It sure is at UP. Because where we struggle with this to continue to see opportunities is we don't want to be reactive when it comes to environmental, right? If you have a spill or you have some significant event, yeah, we have those processes in place. We have the products that we need. We have the services that we can get to contend with that. We want to be proactive, though, right? We want to see research and technology that helps us not only identify where those risks are, but then gives us the absolute best response to that. And again, that could be a process or it could be a product. Even when we talk about like bridges, you know, you go out and you build a bridge, but we want to be thinking about the environmental part of it. Are we building it in the most sensitive environmental area? We don't want that. Are we building in an area where if we have some type of catastrophic event like a derailment, are we putting cars into a river? So the opportunity, again, on environmental, it's all about seeing that proactive risk and then making better business decisions as a result of it. Geotechnical. And I know there's quite a few people in this room that are in that, and this is a huge, broad topic, so I just picked one particular example to demonstrate it. So here on the top is the output of our ground-penetrating radar system, which people in this room have been instrumental in helping us implement. We appreciate that. And we've only had it really for about 2 or 3 years. Here's the opportunity. Down below this, and I realize it's kind of hard to see these pictures, you have a whole different variety of what we call remedial actions, right? Or less technical fixes. Those are all your options, right? You can come in here, right, dig out right at the end of the ties, put in a version of ditches, you can do undercutting, you can do nails into the ground, and you can do underlayments. Where we see the opportunity is for people, both in the railroad and outside the railroad, like here at UIUC, to help us draw the connection. If we see this, whatever this is, right, whatever condition that is, which of those remedial action is the most effective, both from a remedial perspective of getting rid of that issue, but then also from a cost perspective. We see a ton of opportunity in this. So somebody that were to develop a model that could say, well, hey, let me process all your GPR data and then location by location tell you this is what the most effective remedial action is, we'd be very interested in that. Finally, construction management, which we're going to go through a couple examples on. When you think about this as an engineering principle, this is one of those very practical engineering principles, right? That's what construction management is at Union Pacific. It should surprise nobody. The title itself tells you what they do, right? They construct, not renew, they construct new track, bridge, and signal infrastructure. Now, to give you some perspective of what that looks like, though, let's go through a couple examples. So here we have the Illinois high-speed rail, right outside your guys' door. And I know many of the people in this room are aware of it. Think about joint use corridor. We just heard a presentation this morning about, some of the implications of having a joint use corridor, things you have to be cognizant of as you design that track structure. We got higher speeds. We don't operate at 110 anywhere else in our system. Right? So a ton of engineering work went into this. And it really boils down to this list. This is everything that was done, but this is where I draw your attention to. Yes, you start with civil engineering, absolutely. But then you're moving on to track and structural engineering. And then you finally hit that construction management portion. So I'll give you some insight on where we see the opportunity on this, and it'll be present in every one of these examples. If we were building 500 feet of track, I wouldn't even be saying this was an opportunity. But as you can see in this example, 262 miles of renewal, 57 miles of new track, right? That process that's used, that's a very complicated process. From you start with the simple things, right? Things that if I asked all of you, what do you think's in the process, you'd tell me, well, of course, there's people, there's material, and there's equipment, right? Those are the basic foundation of any construction project. But what about permitting? What about scheduling, right? Making sure that you can get it at the right time of the year. What about curfew? You got to work with all the trains, as was mentioned before, to get a time to actually do it. What about the communities that are either in this exact proximity or even close to it? What about state capitals who have concerns about making sure that we're doing it in the most appropriate manner? And I can go on. I can get like 30 of them without even breaking a sweat. When you think about the complexity of that, here's the opportunity. Understanding that process better and then creating tools that allow a person to manage it better. And by person, that could be 100 people or it could be 3. Think about this example. So this is Santa Teresa. So now we're down just west of El Paso. And having had that tour territory before they did this, I can tell you it was a nightmare because you'd basically be coming off what's the Sunset Route, so that runs from Los Angeles to El Paso. It's the highest speed line we have. And then you'd come to El Paso. And this concrete, beautiful double track would neck down into a huge bottleneck right in downtown El Paso. And right then, because you just made this long trip all the way across Southern California, Arizona, and New Mexico, what do you think they need? What do the trains need at that point? Fuel, that's right. Right? So they went ahead and said, you know what, let's eliminate that bottleneck. And they built this phenomenal facility. And I think this is the best picture, but I apologize, it's kind of hard to see here, but here you've got this massive fueling facility where you got a facility on each end, you've got an intermodal yard, you've got a future block swap yard, all in there at one time, right? This thing's like 200 acres. But just think about the complexity. Even if you know nothing else but that picture, I hope you see the same opportunity we see. Is how do you make that the most cost-effective process while still meeting all the constraints that are on any type of construction project? Some of them significant, like in this one, you couldn't have more than 2 tracks out of service. You couldn't reduce the speed below 30. Now, it's not like we just, in every case, get to just say, let's build the new track next to the old track, and then we'll just slide it in over 2 or 3 days, and then we'll connect it up, and everything works. We're being challenged more and more to do construction work within the confines of our existing operation, so we're not having as big of an impact. This one, Tower 55. Now that figure, just take a second and think about that figure. What you have here, you've got 3 different color codes, right? And the key is down here in the bottom right. The gray is Amtrak, the green is BNSF, and the red is UP. And what that's showing you, it's showing you the number of trains per day that go through this Tower 55, which is really 4 interlockers or diamonds, whichever one you want to pick. Right? So just think about that. Amtrak, right? Very important. You don't want to be slowing down Amtrak. But at the same time, they're contending with 15 trains on this route, 15 trains on this route, 11 trains on this route, and this is all happening every day, 365 days a year, all the time. Here's the problem, right? This is very difficult to support, especially when the South is a real growth engine for at least UP and I assume for BNSF too. So then you look at these challenges because the opportunity is obvious, right? Look at that situation, make it better, right? Do certain track upgrades, and I'll get into that. But think about those challenges there. Confined work area, overhead structures. And you think, well, overhead structures, that's not really a big deal, right? No, it's a huge deal. That means I'm not saying we had to be aware of overhead structures. I'm saying we had to replace overhead structures, structures that weren't even ours. And you could imagine the level of cooperation and then eventually an agreement that you have to get to on that. All these things were done as part of this project. Adding main lines, 4 slots, signal upgrades, replacing every single diamond that's in that. And these are all those pictures, right? Here's your diamonds, here's those obstructions overhead. But this is 17 months of work. But look at the return, 25% increase in speed. And Tom mentioned it, but I'll reiterate it. The product we offer our customers is a premium product, right? To offer a premium product, you have to provide a premium service. And service, in most cases, is a function of speed. There was a guy that I was talking to about a couple months ago, and he related it to Amazon Prime. So I don't know if you all have Amazon Prime, but he said, you know, I pay, I think he said $90 or $95 a year to get Amazon Prime, and in return for that, I get 2-day shipping. He goes, you think I'm going to pay $90 a year if 2-day shipping turns into 5-day shipping? Of course not. You're paying for that premium service. You want it in 2 days. This is no different. You can draw the same correlation to this work. Now, last 2 slides. We talk about construction management, and you could group civil engineering in this, and really almost all engineering disciplines as it pertains to UP. This is the part where, what would you do at UP if you came to work with us in this particular position? Now, this is a construction manager, right? They're relatively broad, but just take a minute and think about that. Everything, all construction, tons and tons of networking, problem solving, really working through, you have a stated problem, and then working through, in some cases, thousands of steps to accomplish whatever goal that you've set out to do. And it continues, right? This is the one that I think people get very excited about, in my experience with construction management and civil engineers, that on-site engineering expertise. That's the moment where you get to take the theory and some practical work that you've done and really apply it. And in all those cases, you're helping out people. And they may not be people that always work for UP. They may be people that work for the state. They may be contractors. But at the end of the day, you're still getting a chance to help people solve some type of engineering problem. And then you get down here where it's really about quality and managing our communities and customers that we deal with. So, in closing, that's the 7 engineering principles at UP. I'm going to open it up to any questions you have. Again, it doesn't have to be about this. It can be about any topic you'd like to know more about. Questions? You're going to make it that easy, huh?
Well, first, let's clap. Now questions.
I'm just kind of curious about your background. You went from aerospace to railroad, and you got your MBA. Just curious what differences you saw going from aerospace to more civil engineering type work, and then what made you go to an MBA, and how that's kind of changed how you think about all this.
So I wouldn't change anything the way I did it. I mean, I think it's not a surprise to probably anybody in this room being an engineer that, you know, for almost 2.5 years of, at least in my experience, it was really no different between me and a civil and a mechanical engineer. I learned the same skills as an aerospace engineer. I did that for about 7 years up for Northwest Airlines as a propulsion engineer for them. I apply the exact same skills in the jobs I've had at the railroad. Now, as far as getting my MBA, I use it more than I actually thought I would, just to be very candid about it. I always thought that I would want to get a master's in engineering, and I think someday I still will. But where I was with trying to transition to a railroad environment, knowing that we do plenty of engineering, but that's not all of our jobs. We have to run a business as well. I thought the MBA would be a good thing to complement my engineering degree. Yes, ma'am.
Getting better and better, and I'm assuming you get a lot of data these days from all these locations that you guys have. What are you thinking about how these 7 disciplines going to collaborate on these data and communications and
Sure.
anything about
So they're absolutely linked. In fact, I think one thing that we have to get a lot better at is, to your point, we recognize the fact that we have a lot of data. Some days more than we know what to do with. We really need to be a little more surgical about, okay, if these are our principles and these are the things that are important, what subset of the total data do we need to really study, really focus on, to really understand, and then apply to whatever principle we're talking about? And I think it's born out of the fact that we always haven't had data. I mean, it sounds strange, and I probably will sound old, but you think about even 15 years ago, what this industry looked like. We didn't have, in all cases, geometry cars and all the research that's been done. So it's kind of a new frontier for us. But that's what makes it exciting, too. I mean, that's why I'm excited to see all of you here, is the fact that you will be the future minds that find a way to utilize that. And as a result, like the presentations we saw this morning, make us safer, make us more reliable, make us more efficient. Did that answer your question? Good. Who else? Go ahead, Chris.
So what do you think are the most important, or is the most important advancement you'd like to see in track engineering in the next decade, let's say? What's the biggest opportunity for improvement there?
I think it's really going to come down to, I'm going to pick 2, because it's hard for me to pick between the 2. I think it's going to come down to to tie technology and where that goes. And then also I think it's going to come down to safety inspections. What can we do over the next 20 years to make us even better at the inspection process? From human beings to computers to geometry cars, I think those will be the 2 big opportunities. At least at UP. I'm not obviously talking for any of the other railroads. Yes, sir.
Your railroads own a huge amount of habitat.
Yes, sir.
Can you say something about bioengineering and fitting that into the environment?
Yeah, so we don't do a tremendous amount of it. Where we still see an opportunity for it is with the scrapping of the wood ties. All right, there's always been, for decades, there's been a strong desire, and in some cases there have been practical applications of taking biofuels like scrap ties and burning them for electricity. We do that to some level, but I think there's a lot more opportunity for that, even to the point where we're actually running equipment, not locomotives necessarily, but even like the equipment we use in engineering, off of something like biodiesel and other biofuels that can be more environmentally friendly.
What about vegetation?
The vegetation, we're very cautious about vegetation. We have very strict property lines, and we understand what's not on our property is not for us to touch. We do obviously some maintenance along our right-of-way to make sure that we still have clear line of sights for trains so they can see other trains or engineering people or road crossings. But for the most part, it kind of stays the way it is. Does that answer your question? Okay. Yes?
I wanted to ask, I was kind of curious, so you're vice president of track programs, but what were some of the positions you had before this that kind of prepared you for that, and experiences that you had that prepared you?
Believe it or not, I started right where a couple of you have already signed up to start. I started as a management trainee. You go through a full year of really not having any responsibility except to learn and to visit different people across the system to get different perspective on how to railroad. It's a great program. It's evolved. It's way better today than it was when I went through it. But if you've never looked into it, please do. I'm not going to tell you it's a chance to always apply 100% of your technical degree that you're going to get or have gotten. But it's a great balance between being an engineer and also having that, it's going to sound kind of funny, but that kind of that practical reward on a daily basis that you did something, right? That the team you're with, whether you were with them or they were out them by themselves and you were managing them, you fundamentally improved something. You get to walk away on a particular day and see, you know what, we put in this many ties, or we solved this engineering problem, or we modified this piece of equipment. It's just really cool. I don't know how to say it any better than that. Yep. So that in this position, I've done a lot of different positions. On the maintenance side, I've spent, that's why I know a number of people in this room. I've spent time on the research and development side, where we've partnered with UIUC. We've been at the same ARIMA conferences. We've had the same arguments, slash debates. And then after that, it's been different operating positions. So, what else?
What are some of the systemic risks that you see going forward?
So in all aspects of our business, the very first one's just complacency. You can pick employee injuries, you can pick derailments, you can pick grade crossing incidents, and you'll find that most of us will always agree it's complacency. It's people thinking that it's not going to happen to them. We had our best safety record ever in my group last year, but we still sent 28 people home, not in the condition they came to their work. And if you really root cause that, in many of those cases, it was complacency. After that, the systemic risks you see, the one we're experiencing all the time lately in the last, say, 3 to 5 years, is Mother Nature. We have had some of the most significant, what we call outages, which is where we've lost a portion of our railroad for anywhere from an hour to one we're contending with right now is many days. Those are the two biggest ones. They always have been, and when we finally get the safety part of personal injuries resolved, that'll be the proudest moment of everybody at Union Pacific. In fact, a record that we set, and it may seem, you may be surprised by this, and it may seem insignificant to you, but it's extremely significant to us. We've been around for 154 years, and last year was the first year we didn't have a fatality. And that is just, we're very proud of that. So, does that answer your question?
Yeah.
Okay. Who else? My teams at work are harder than this. Come on now. Yes, ma'am.
Thanks. Could you elaborate more on material optimization methods and if there are any models to visualize?
So there's not. That's the opportunity. That's what we're looking for you and other people here at UIUC to help us with. And I shouldn't say that there's like zero. I don't think there's zero. There's plenty of them that have been out there that have been applied, but not in like a really comprehensive perspective. And that's what we're really hoping that you guys and gals can do.
Thank you.
Someday, I'll be really proud when we know all of that, and we're doing just that. Yes?
As you might expect, my question touches grass ties, and I would like to know, what do you think would be the future material for grass ties in your railroad?
That's a great question, too. I don't think there'll ever be one. You know, we're actually moving from a philosophy of, okay, wood tie, wood tie, wood tie, to one in which what we call them at UP is called a tiered standard, right? So if you think about, you've got concrete, you've got wood, you've got composite, you've got steel ties, and then within all those categories, you also have different lengths, right? 9-foot tie, 8-foot 6 tie, 8-foot tie. We're very focused on saying, where do you, when you're going to go out and do renewal, you're going to do track construction, what is it, the asset we really need to put in that track? So for example, and it's kind of a crazy example, if you've got a route that has one train a day, does anybody think we should go in and put in concrete ties knowing that they're the most expensive, right? No, of course not. But as you dig into that relatively simple example, maybe that's in an area where it contends with a lot of moisture, right? Now that actually might warrant putting in a composite tie then. Something that we know if we don't, the expected life of the wood tie is significantly decayed versus like a dry, arid climate. So we have and it's oversimplifies it, but we have a map, and it shows every single one of our subdivisions, and we call out very specifically every tie. Now, the exciting part of your question is someday we'll find very cost-effective ways, more than we already have, to make concrete ties and composite ties, and then I think you will see us continue to move that way, especially in the composite tie area, because we know the life cycle of those is, or at least we hope someday they'll be 40, 50 years, and that's a huge benefit for everybody involved. Does that answer your question? Okay. Who else? Go ahead.
One thing I saw you talked about was a lot of, and possibly adding main tracks in areas that you need them for capacity. And how do you justify putting in a main track when you may have a possible improvements in the future with PTC and having more capacity on a single main track?
Yeah, so that's, believe it or not, that's Tom's whole group. That's a big part of what they do. So because we don't know what the impact of PTC is going to be entirely, we typically don't consider that yet. You're right, though, in the future we will. So when it comes to deciding where do we put in an extra track, whether that's a mile long or 55 miles long, it's all about volume. It's about a theoretical capacity of our existing track structure versus what we think, looking over 5 or 10 years, what the business is going to need. See, one of the hardest things we do, or the situations we run into, is when we suddenly get a peak in a particular type of business on a particular type of route. We're very happy to have that business, but if we can't support it, we're actually, in some cases, doing an injustice because we can't provide the premium service we want to. So that's when we have to step back and even today look 5 years, 10 years, 15 years from now and say, okay, to the best we can tell, what is the market going to look like, and what does that look like on our railroad, and then start putting ties and steel in the ground now to be prepared for that. Does that make sense? Yeah. It's a massive undertaking. I mean, Tom has some of the smartest people at Union Pacific Railroad working on just those types of problems. Yes?
So they've already asked you which are the fashions that you can predict for track, but which are the biggest changes that you have seen in track engineering for your career?
I would say most of the biggest changes, I mean, in my career is not as long as some at UP, but just in my experience, it's been really two things: rail technology, and I mean all aspects of it, from the way we make it, or the way that our suppliers make it, but the way we spec it, to actually how we handle it, right? All the way from the installation to the monthly or every month or every quarter testing we do. So all aspects of that. And then the other one goes back to her question, is even though I told you I don't think we're nearly as good as we will be someday, the other biggest evolution has been in data management and really leveraging that to make the most informed decisions that benefit UP.
I was going to ask, kind of to piggyback on Joseph's question about tie types, I was wondering if you had any things like future fastening systems.
All right. So the question is, do I have an opinion on future fastener standards? So actually the answer is still the same. We actually have a tiered standard for fasteners. We know that in some cases an elastic fastener, whether it's on a concrete or a wood tie, is absolutely the best thing to put on. But we also know there's plenty of places where putting 3 or 4 spikes in a standard plate is plenty sufficient. I think where we'll still see some opportunity is to understand, even better than we do, gauge restraint. Right? At the end of the day, that's one of the most important things to us, because we obviously don't want to have those very catastrophic derailments. So really understanding exactly how much gauge restraint over the life of a tie do you get with this fastener versus this one versus this one versus that one. That's why I was, Riley and I were talking out. I'm still very interested in the work that his team and him did on pads and insulators, right? Because they now know better than we ever have known, this is exactly how long a particular product lasts versus this product versus this product. If you take that information, there's no way you don't make a better decision from a safety and a reliability perspective with that in hand.
So I'd actually like to ask both you and Tom to give our students a bit of advice. And I'll say, the question I'll ask is, beyond striving for engineering excellence in their studies and research, what do you think are the most 2 or 3 important attributes that they should strive to develop in themselves to be successful working for the railroad?
So the first one's easy. It's leadership. When people come to the railroad, unless you go into very niche groups, you're going to be leading people. It could be one person, it could be 100 people, it could be 1,000 people. And whether you feel like you're in a position now to get better at leading, I promise you that's true every day you are. Right? We want the absolute strongest leaders. We want the intelligence you have. We want the analytical problem solving you have. But we also want that ability to go and handle things like conflict management, handle difficult situations, high intensity, stressful situations. So anything you can do to build your leadership skills is exceptionally important to us. After that, it's practical knowledge, okay? And there's like a whole bunch of people smiling, so that one must have hit home. It's absolutely awesome to be the world's best engineer. But as we talked about last night and again this morning, where you make a significant and real change, and this is just my opinion now, is when you can develop practical solutions based on extremely complicated theories, modeling, whatever you want to call that, together. It's all about the practicality. I have met so many people that have been so intelligent, but to take that intelligent thought they have and turn it into something that practically benefits people, it's a stretch for them because it's something you have to practice. That's just not something you typically have or you typically know. You have to really strive for that. So those are my 2 pieces of advice. And I think Tom stepped out. So I know Tom pretty well, though, and I'll tell you, his big thing is going to be communication. You know, we always talk at UP, 90% of all problems are born out of communication or the lack of communication. If you don't believe that, wait till you come and you get a job. I promise you can call me up 2 years from now and tell me how right I was, because it really is true. Communication, communication, communication. When you think you're over-communicating, just go ahead and communicate some more because you're not quite. And, you know, there's some professions where that may not be always true, but in a railroad environment, with all the dynamics that we face every day, from simple things like what are you going to do to spend your day, to managing people, to managing conflict, to managing all the things that we have to do, communication is so important. If we were 3,000 miles of railroad, it'd be easy. But we're 33,000 miles of railroad. And by the way, too, in some cases, different groups have competing goals, right? So anytime you're working with somebody where you have a competing goal with them, the best thing you can ever do is over-communicate. So I guarantee that would be his number 1. What else? Yes?
You talked about optimizing the lifespan of different components so that you go through, you do a track renewal, and just putting everything fresh. Has there been any thought to maybe doing a renewal a little bit earlier and then looking for components that could maybe be reused? Like if you go through and replace ties, and instead of going through and replacing every third, you replace all of them and then reuse?
No, that's a great question, and absolutely, we do that today. And to clarify one thing, when we talk about optimizing to a renewal cycle, it doesn't have to be the first renewal cycle, right? And I realize you understand that, but just to be clear, to keep using the pad example, right? If we know 3.8 billion gross tons is going to be the rail, well, if we can make a pad that's 7.6, hey, that's great, right? And then we will absolutely reuse it. But we reuse a ton of material that we get especially those high-priced components. Like even plenty of people on the maintenance side do it. You go to a diamond, right? That maybe you put in a couple inserts a year ago. Well, those inserts typically last 25, 30 years. There's no reason to throw that away. So they take that insert and they, trash the rest of it and put it in the scrap bin, but they keep those inserts. And on track programs, we do it a lot. So, no, it's a great question. Anybody else?
Hi. You were asked a question earlier about new technologies, and you mentioned safety inspection methods. So what areas are you looking at, or that may or may not be worked on right now?
I think they're being worked on. I think, though, where we continue to be challenged is, we have people, we have equipment that's going around all the time, but how can you make that as real time as possible? One of the hardest things to ever hear about is where we say, okay, if we had just sent a track inspector 2 hours earlier, he or she would have found that broken rail. So when I gave that example of the autonomous vehicle that can do geometry, it's things like that, things that we can carry on the trains, which side benefit, they actually get to have exerted on them real in-train forces and constantly know if we're going to have a problem. Does that make sense? Okay. Yes? Okay, so and I'm just going to paraphrase that, but the question is to people that do research, what's my advice to be able to bridge the gap between theoretical and practical application? So again, we were just talking about this a few minutes ago. My advice to that is I think there's always an interest to continue to research new ideas or new frontiers or new areas. When it comes to practical, it's typically like a railroad like UP coming on the back end of some type of research and saying, okay, well now let's go ahead and fund taking that and turn it into practical. Because oftentimes we'll hear of different research topics, and it could be true of suppliers too with products they sell us. You have a concept of what you think you want to do or what you are going to do, and we have a concept of what we think the practical application will be. But oftentimes those two completely miss each other for reasons that may not be any more your fault than my fault. Where if you stop halfway through and you say, okay, this is where our outcome is. This is what the research said. These are our conclusions. And now you ask the question, okay, railroad or whoever, what about an opportunity to continue to fund, but then you neck down that focus area just to those one or two things. I mean, some of the things we saw this morning were fascinating. A tool that can help to understand the impact of slow orders. Now, there was a ton of good content in there, but probably about 30% of it was really most interesting to me. And so that's an example where I come back and say, well, you know what, for that 30% of that excellent work you did, now how can we neck that down to be very practical, whether that's a software or whether that's an algorithm that we can use. Does that make sense? Anybody else? Okay. Yes.